Hello everyone. Okay, we're going to continue with the free variable KMAP. If you didn't watch the previous lecture, you have to watch it. Otherwise, you will be lost. You will not be able to understand what is going on. Okay, so we're going to do 7 examples, and they will be more complex than examples from the previous lecture. So we're building up on the complexity and difficulty level. So let's start right away. So example a function, we're going to stay with three variable functions today. Next lecture we'll do four variable functions and four variable. Right, so let's look at this example. Now, in the previous examples, we had function in form of this, sum of minterms, and we could just transfer minterms into the map and group them and solve it. Now there's a problem here. We have a function in form of the algebraic equation. All right, so we can also transfer this function into the KMAP and look at the KMAP to see if this function can be simplified. Let's do it. The first thing you do is you're going to do the variable fields, right? So we know that variable fields are as follows. This is variable field x, this is variable field y, and middle two columns are variable z. I wonder why is this changing color? It doesn't matter. All right. Now, how do I plot the function? Not the minterms, but the function. Okay, let's look at this. We have two terms, two variable term and one variable term. The two variable term is missing one variable, right? Because function is three variables, and you have two variables. That means this term is a pair, was generated by the pair. This term was generated by a quad, because the two variables are missing, and only quad can eliminate two variables. All right, so this is a pair somewhere on the map, x prime y. Let's see where pair x prime y is. X prime, so this pair is entirely within x prime and entirely within y. So it looks like this is the pair. This x prime y is right here, this pair, right? Okay, because it's in x prime and it's in y. So instead of going from here to from map to algebraic equation, we go from algebraic equation back to the map. Now, y. Y is a quad. Quad 4, that means 4 adjacent fields. Where's field y? Field y is probably right? So this field y is right. So what we did, we transferred our algebraic equation into a map. And now let's see if we can simplify it. Looks like we have a quad here. This entire thing is a quad right here. So you see this pair x prime y is right here. It's included in this quad. So that means it is a redundant term. We can basically throw it out. All right, so now we're going to see what this quad is. This quad is just y, right? Because all four fields are within a variable field y. So look at this. X prime y plus y is equal to y. Yeah, of course, because of the following. If we if we factor out y out of this two, we're going to have x prime plus 1. And that is equal. So we proved algebraically that this one is equal to y. And we also put it on a map and proved that this map will give us solution y. Yeah, why do we even bother to draw the map and do the variable fields and transfer these terms into map to prove that this y? This is such a simple solution here, because it will get more complex, definitely. You will not be able, sometimes you will not be able to figure out how to express algebraically the simple solution. Map will tell you right away. All right, let's look at the next map. Variable fields. Let's try to do black. Let's see if black works. Okay. Field X, y and here z. Let's transfer the z prime. This looks like it's a quad because two variables are missing. Where's z prime? Probably outside of z. So this is the 4. This is the quad z prime. Now xz, where's xz? xz is a pair that exists somewhere on the map within variable x and variable z. So variable x is a bottom, right? Variable z is right here. So variable pair x z is right here. So we transferred this function onto the map. This doesn't exist on the function. So look at this. This is very nice and symmetrical map, right? So that means the solution will be quite simple. All right, let's see. So we have the following. Definitely a quad right here, right? We see the quad. We don't see octet, but we see a quad. This quad is x. So we'll put it x. And M2 and M0, those are not singles. And this is not a pair, M2 and M0. This is a quad. You can cover M2 and M0 with the quad when we attach this to M4 and M6. So this quad is Z prime. So X plus Z prime. So we can, Z prime plus XZ is actually X plus Z prime. You see, you don't see it because you cannot factor anything out of this tool. If you want to do it algebraically, you have to use the distributive law. Distribute Z prime into XZ right here. And use distributive law, and you're going to see that this two terms is equal to Z prime. All right. If you don't know distributive law, you're doomed. But if you know how to use the map, you can come up with this without knowing it. Okay? That's the power of the map. Okay, now we're going to have really something very complex. All right, now let's solve this. Let's go into black pen. Let's do our variables around it: x, y, and z. Okay. All right. First of all, this is algebraic expression, and this is canonical expression. Sum of mean terms, and this one is some kind of a algebraic expression, one term. Now, what do we do? We're going to turn this into, we're going to prime this. We can turn this into a mean term. Okay. So let's prime this first. So this is equal to, when you prime it, you're going to change all the variables and operators into opposites. So this is x becomes x prime, plus becomes product, and so let's continue y z prime, plus sum of 0, 3, 6, 7. I hate when marker changes the color by itself. Okay, let's do this plus here. All right, so now this is mean term 2. X prime y z prime is mean term 2. Why? Because you know the binary method. If mean term has a prime variable, you put 0 above it, and unprime is 1, and prime is 0. All right, so 0, 1, 0 is mean term 2. All right, let's change it to black, plus sum of mean term 0, 3, 6. So what we have basically is mean term sum of mean term 0, 2, 3, 6, 7. All right. Mean term 2, this mean term 2, I incorporated this right here. This is crazy. All right, so let's put it on a map. Okay, so we have a function 0, 2, 3, 6, 7. 0, 2, 3, 6, 7. All right, so what do I have here? I see a quad. What do you see? I see a quad, definitely. This big thing is a quad. All right, so this function is a quad y. You see this entire group is in variable y. X and z are gone, so this is y plus. Now we have for min term 0. Min term 0 is not a single, it's a pair. We're going to attach this pair as a wraparound pair right here. So min term 0 will be attached to min term 2 as wraparound pair. And this min term 2 is x prime. This entire group is in x prime and it's z prime. So plus x prime z prime. This entire function can be simplified into this. Okay, and then built into a gate diagram. All right, everybody okay? All right, so let's. Oh, this one. All right, so let's do the fields again. X, Y, Z, and let's. Oh my, that's going to be a lot of plug-in. All right, I don't like this. This prime actually. I'll show you how to deal with this. So this is xy prime. Where's xy prime? This is a pair, xy prime, right? Because it's three variable function. You see these two variables? That means there's a pair because one variable is missing. xy prime, x and y prime. So this is min term 4 and 5. This is min term 4 and 5, xy prime. But this is prime, xy prime, prime. That means not xy prime. So not min term 4 and 5. So this term will be expressed on a map everywhere else, not xy prime. So if this is x prime, m4 and 5 is xy prime, this not xy prime will be all sigma. Now xyz will be right here, min term 7. You see, xyz. This is a single. Where is the single xyz? That's min term 7. Now x prime. Two variables are missing out of this term. That means it's a quad x prime. Where's quad x prime? This is entire row right here. This is quad x prime. And we already have it marked. So we don't mark it again. Y prime. Y prime. This is quad y prime. So this is quad y prime. Two variables are missing. That means it's a quad. Y prime is here. 0, 1, 4, and 5. So we're going to do the following. 0, 1, 4, and 5. And quad z prime is this 0, 4, 2, and 6. So now, after adding all those fields here, look what we have. We have this beautiful group that is called, everybody remembers? Yes, this is what this group is. And octet eliminates 3 variables are gone. And we have a 3 variable function. So guess what? If 3 variables are gone and the entire function is covered with one entire map, that means this entire thing is what it means. Look at this function. See this? It's a hassle to build a gate diagram with this function. This all those 1, 2, 3, 4, 5 terms. And guess what? If you build a diagram of just one, the signal one, it will do exactly the same as this entire thing. So you see how much simpler it is to do this versus this. All right, let's look at we have 3 more. Okay, let's look at the following. Now, this one is interesting. If you have a function that is sum of min term 0, 3 plus product of max term 1, 257, you have to do the following. This is a main operator plus. That means you have to change the products of 1257 into min terms. Okay, so this term has to be changed into some of min terms, product of max terms. You cannot change this term into product of max terms and add to this products of max terms, because products of max terms are products. That means there has to be product times product, not product plus product. So if you have this main operator plus, this has to be changed into sum. Sum of min terms plus sum of min terms, yes, that can be done. All right, so let's change it. So let's continue. This one is equal to sum of min terms 0 and 3 plus sum of min terms. If the function is product of max and 1, 2, 5, 7, that means it's a sum of min term of complementary subscript. So that means 0, 3, 4, and 6. All right, so now we can add this. As you see, we have a repetitive min term. 0 and 3 repeats itself right here. So we don't have two zeros max min terms and two three min terms. This one's actually repeated. So we cross it out. And our function is sum of min terms 0, 3, 4, and 6. All right, so this one is a canonical expression. Let's do the map and change it into algebraic expression. All right, map variable x, field y, field z. Let's transfer this into the map. And this one is 0 is here, 3 is here, 4 is here, and 6 is here. That's a scattered map. Allows this scattered. The function will not be that simple. All right, now what I see is a lot of singles, not really. This one is a pair here, as well as M6 is not a single, it's a pair with M4 wraparound pair. M3 is a single, cannot attach M3 to M0 or M3 to M6. Those diagonals don't exist. Okay, diagonal pair. All right, so let's group them in terms. So you have to cover all the min terms and you can reuse them. So let's do this first. Min terms 0 and 4. I'm going to continue this here, right? Min terms 0 and 4. It's a pair. That means one variable is missing out of 3. I see this group being entirely within z prime and y prime. So it's a y prime, z prime. Wow, this is crazy. Now, this pair right here, wraparound pair, are within x and z prime plus x z prime. This z prime must be black. Okay, and this is unfortunately is a single M3 is x prime yz plus x prime y z z. All right, it's a nice mixture of red and black. Okay, we don't care about it, right? So this is the simplest solution because that's what map is. You cannot simplify this, no matter what, how bad you try, you cannot simplify this. Okay, so let's look at two more examples. Very easy. So the first, now let's look at this. It's a product of max terms 0, 4, and 7. Let's look at the field. Okay, my wife just interrupted us, my lovely wife. Trying to learn as well, but let's remove her from the room. So this is x, y, and z. All right. Guess what? Instead of converting this into sum of min terms, we can do the following. Min terms are expressed as ones on a map. So guess what? Max terms are expressed as zeros. So we put max term, for field 0, it's max term. field 4 is maximum. They are expressed here at field 7. All right. So the rest of the field will be okay. So you don't have to turn this maximum. You can just plot max right on the map. All right. So we have but we have to cover meters. So do we have a quad? M1 and 5 and 2 and 2 and 6. This is not a quad. Those are two disconnected. All right, so we don't have a, I don't see quad here, so I have a pairs. How many pairs can we have? Looks like we have one here, one in 6, right? All right, let's do it. So the pairs will be as follows. I'm going to try to use blue. This pair is variable x is gone because transform x with prime. So it looks like it's entirely within y prime z. So this is y, this term is y prime z. This pair will generate term x prime y. And this is not a single. This M6 is not a single. It can be attached to M2. So this is a pair. And this pair is y prime. This is our answer. So function that is expressed as a product of maximum 0 and 7 can be expressed as an algebraic equation in algebraic term. Okay, and do it. Last one is all right. Last example is product of maximum 1. All right, let's do the variable field x, y, z. And the product of maximum 1 is right here. Product means this part of the map is 0, right? 1. Okay, so the rest of it is 1s. All right, we have a very well populated map. So we definitely don't have an octet. Octet is 8. We don't have 8 interns. Jason. Okay, we have definitely the quad right here. There's a quad x, right? Quad eliminates two variables. Oops, this is actually a, b, c. Sorry. So let's redo it. A, b, and c. Oh, I didn't say a, b, and c. All right, let's redo it. A, b, and c. Do you like this? This is not z. This is c. Okay. A, b, and c. So now we have an entire row of a plus the next group right here. This is quad B, right? This group generates term B. And this one, the M0 is not a single. M0 is a quad. Can be incorporated right here in the reference quad. So this one is C prime. So look at this. Pi of 0, pi of 1, maximum 1 can be expressed this way. And this is really maximum 1 because maximum is a sum of all three variables of the function a plus b plus c prime. And you know this is maximum 1 for the maximum lecture. And that would be it for today. All right, that's great. Let me see here.